Hi guys, Assalamualaikum warahmatullahi wabarakatuh. Today I, Akilah Najwa, and my group mate Saidatul Nur Shahirah and Nisha Izati want to present our case study related to chapter 5, which is metal. We will explain to you guys the process that involve an application in metals. Metal is processed into different shapes by various manufacturing methods. There are several common methods of metals in industry. Let's take a look one by one. First is casting. Casting is a process which molten metal is poured into a mold that contains a hollow cavity of desired geometrical shape and allowed to cool down to form solidified part. Second is hot and cold pressing. Hot pressing, defined as the plastic deformation of material, is at above the recrystallization temperature. For the cool pressing, defined when they're working under the recrystallization temperature. Third is extrusion. Extrusion process in which cylinder billet inside a closed cavity is forced to flow through a die of a desired cross-section. Fourth is fogging process. Metal fogging is a metal forming process that involves applying compressive forces to a workpiece to deform it and create a desired geometric change to material. The last one is wire and dip drawing method. For dip drawing is a sheet metal forming process in which a sheet metal blank is radially drawn into a forming die. Wire drawing is a process used to reduce the cross-section of a wire by pulling the wire through a single or series of drawing dies. There is 5 common methods that involve in method. Here is the application.
I will talk about the steel application in car body for the first application of metals. Undoubtedly, the most common material used in automotive production is steel. Approximately, every model is made with some steel simply because it is cheap, strong, readily accessible, and easy to operate. Generally, you will find this steel in sections like brakes, engine, exhaust, wheels, chassis, and also roof. Steel is very durable, powerful, and sturdy, providing safety and improving the way of a car drives and handles. Other than that, steel also easy to manufacture. Simple steel manufacturing can cause the adaptable to mass productions, allows better stamping and various welding techniques, enabling cars to be made in higher volumes and at a lower price. Some steel is also malleable. It can be molded to produce any other component in car, such as an engine block. Steel is able to be poured into molds and cooled. Hence, using welding methods, steel is also easy to bind together. That's all from me about the application of steel in a car body. Next, we will hear about the second application of the metals.
Aluminum and steel are also used in an industrial refrigerator. According to the Aluminium Association, aluminum alloys can be divided into 3 groups: commercially pure aluminum, heat-treated alloys, and alloys that are not heat-treated. Alloys are mixtures of 2 or more metals shaped to produce new metals with enhanced mechanical properties and other properties of the base metal along with other elements or materials. Aluminum alloys are produced by adding certain components to the aluminum base, which are copper, iron, magnesium, manganese, and zinc. Alloy is equal to metal A plus metal B and so on. The resulting alloys are stronger than 1100 commercially pure aluminum, making them more suitable for the manufacturing of heavy equipment that needs to be used in hectic food service operations. Is stainless steel. Stainless steel is the most common kind of steel used in the manufacture of industrial refrigeration. This includes 300 series stainless steel and a stainless alloy of at least 16% chromium, no more than 0.15% carbon and nickel, and 400 series stainless steel, which is made from a higher volume of carbon. The more carbon a stainless steel grade holds, the more powerful it is. The most commonly used stainless steel grades for refrigeration systems are 304, 316, and 430.